Hello and welcome to Friday's Maths, where we are reading and interpreting pie charts, hence the little pie on the screen. So, little rewind to yesterday, we started looking at pie charts, bar charts and tally charts, and we started looking at the fact that a pie chart is really useful to show parts of a whole. The circle represents the whole thing, and then each section represents part of that whole. Pie charts are really useful to show half of the number and quarter of the number as well. Okay, right, let's get started. Here is our discover problem, and the first part says, how could you represent the children at the fancy dress party with a pie chart? So I want us to have a go. First of all, I would do a tally chart, or at least some kind of table, so you can see how many superheroes there are, how many princesses, how many cats, and how many pirates. Once you've got that, you can then work out how many equal parts your pie chart is going to be split into, because each part will represent a child. And then you can have a go at colouring in your pie chart to represent how many pirates, how many cats, how many princesses, and how many superheroes. Right. Once you've done that, question B is then 1 superhero, 1 cat, and 2 pirates leave early. What would the pie chart look like now? So a superhero, a cat, and 2 pirates leave early. What would your pie chart look like now? Have a go, pause the video, have a go and see if you can draw these out. So first of all, we need to make sure we've got some kind of tally chart that shows how many of each there were. So there was 5 superheroes, 1 princess, 3 cats, and 3 pirates. First of all, let's find out how many people were at this party altogether. What was the whole? So there was 12 children, which means the pie must be divided into 12 equal segments, 12 equal parts, and each part represents a child. So if I was you, I'd have drawn my circle, I'd have cut it into 4 straight away into quarters, and then I'd have cut each quarter into 3 parts. So altogether we've got 12 parts, and then it's a case of just colouring them in. So superheroes need to be coloured in, and there's 5, so that's the red ones here. 1 princess, so that's the yellow. 3 cats, so that's the purple, and 3 pirates, so that's the white. If you look at this, what can you tell really easily about the amount of pirates and the amount of cats? Well, hopefully you can tell that they are both equal. There's the same amount of pirates and the same amount of cats. And you can also tell that they are a quarter. So a quarter of the children were pirates and a quarter of the children were cats. Lovely. So B then. B said that 1 superhero, 1 cat and 2 pirates have now left. So you might want to adapt your tally chart. So there's only 4 superheroes now. There is only 2 cats now, and there's only 1 pirate. So now, rather there being 12 people, or 12 children, there are now only 8 children. So now there's only going to be 8 segments in your pie chart, and each segment will take up more of the chart because there's less segments, so each section is then bigger. So there's now 4 pirates. So if it's 4 out of 8 segments, what can we say about the pirates? Well, we can say that there is now half of the party was now pirates. 2 of the, not pirates, the superheroes. Sorry, I'm reading the wrong label there. So 4 of the superheroes, so half of the children were superheroes. There's only 1 pirate now because 2 of them left. There's 2 cats because 1 of the cats left. And there's still 1 princess because she's not got anywhere. So it says here, I noticed that the section for cat costumes is the same size on both pie charts. I wonder why. Well, up here, each segment was worth less because there was 12 segments, and it was 3 out of 12. So that's a quarter of the children were cats. Down here, there's now there's now less segments, so each segment takes up more of the pie chart. So there was 8 segments and 2 of them were cats. So 2 out of 8 is also the same as a quarter. Okay then, it's think together time. So, some children have voted for their favourite party games. Each segment represents 1 child, and we've got boys on the left, girls on the right. So to begin with, I'm just going to ask a few simple questions to show that we understand these pie charts. How many boys voted? Well, if each segment represents one child, there are 12 segments, so there was 12 boys. How many girls voted? Well, if each segment represents one child, there are 20 segments, so there were 20 girls that voted. What colour is musical statues represented by? That would be yellow. What colour is dance competition represented by? That would be white. Right, question then. Is it true that the same number of boys and girls like musical statues? Is that true or false? So the same number of boys and the same number of girls like musical statues. Well, for musical statues, we were looking at the yellow part, and it shows me that there was 3 segments coloured in. So that was 3 boys that like musical statues. And on the girls, it was 5 girls that like musical statues. So actually that's false because more girls liked it than boys. Now, a misconception here, and this is where it's easy to get confused sometimes, is the fact that musical statues is worth a quarter on both of those pie charts. However, the question didn't ask for what fraction of boys and girls likes musical statues. If you said, is the fraction of boys and girls that like musical statues the same? The answer would be yes, because it would be a quarter of each. But the question said the same number. And we've got to remember that each segment represents one child. So there was 3 boys and there was 5 girls. So it's not the same number of children. So, question 2. Before a party, some children voted for their favourite type of music, and that's shown by the first pie chart. However, at the party, 4 more children voted. What did these children vote for? And this is shown by the second pie chart. So, if we look at these 2 pie charts, you can see that they are split into a different number of segments. And that's because on the bottom pie chart, that's got 4 more segments because 4 more children had voted, and each segment is worth 1 child. How many children voted for pop music before the party? Oh, sorry, you can't see pop music label on there, but it's blue. So 4 voted it before the party. At the party, after more children voted, how many children had voted for pop music then? Still 4. So that's not changed. So the children who voted afterwards haven't voted for pop music. Let's look at rock. What colour is rock represented by? Yellow. So how many children voted for rock music before the party? 2. And how many children had voted for the rock music at the party or after the party? 4. So that's gone up by 2. So that tells me that 2 of the children who voted at the party must have voted for rock music. If we then look at rap music, before the party, how many children voted for rap? 3. How many children voted for rap at the party? Now it's gone up to 5. It's increased by 2. So 2 children must have chosen rap music and 2 children must have chosen rock music. Okay then, challenge time. And I think we can all have a go at this because we might need this later on in our workbook. So 24 people entered a talent show. The pie chart shows what they performed. So they performed magic, comedy, dancing and singing. Now, before I even look at the questions, I want to look at this pie chart. How many parts is this pie chart split into? Well, it's split into 8. But the question told me that 24 people had entered the talent show. So we could have split this pie chart into 24 segments. But what we'll find is, just like how they've now stopped writing the numbers on the pie chart, we also stop doing 1 segment per person and we start kind of grouping segments together to make it easier, a little bit like when we simplify, makes the numbers easier, makes it visually easier to see. So if there's 8 segments and 24 people, how many people must each segment be worth? If there's 24 people all together and that's been split into 8 segments, how many people must be represented by 1 segment? How many 8s go into 24? Well, the answer is 3. So there were 3 people per segment. So how many people performed magic? Well, that's one segment, so it would be 3. How many people performed dancing? Well, that's 3 segments, and each segment's worth 3 people, so 3 times 3 is 9. So, questions then. How many more people danced than performed magic? Well, you've just told me that 9 people danced. How many people performed magic? You've already told me it's 3. So, how many people difference? 6. 6 people difference. How many people did not sing? How many people did not sing? Well, 1, 2, 3, 4, 5, 6 of those segments were people that didn't sing, and each one of those segments is worth 3, so 6 times 3 is 18. Lovely, well done. It's practice book time, so today we are on page 102, reading and interpreting pie charts. Okay, pause the video, have a go at question 1. Answer time. So number 1A was quite nice and easy. So altogether there was 10 votes, there was 10 segments, so each segment is worth 1. So there was 5 bananas, so you should have coloured 5 segments in for bananas, 1 kiwi, so 1 kiwi segment, 4 strawberries, so 4 segments for the strawberries. B then, little bit trickier. This time we've got to look at a bar chart to work out the numbers. So 2 people liked orange. Nobody liked coffee. 2 people liked lemon. And if I look at chocolate, 6 people liked chocolate. And I've just written these along the bottom to help me. So I had 6, 7, 8, 9, 10. So 10 children were asked. However, when I look at the pie chart is only in 5 sections. So the whole is worth 10, but it's split into 5 parts. So what's each part worth then? Well, one part must be worth 2 because 2 times 5 is 10. So each part is worth 2. So orange then, 2 people liked it. So I need to colour in one segment because it's worth 2. Lemon, 2 people liked it. So I need to colour in 1 segment because each segment's worth 2. And for chocolate, 6 people liked it. So I need to colour in 3 segments because each segment is worth 2. So it should look a bit like mine. So, C then. 18 people were asked what pet they owned. 3 more people had dogs than rabbits and the rest had cats. So, I know that my whole is 18. 18 people were asked. How many segments have we got? 1, 2, 3, 4, 5, 6. So what the whole is worth 18 people. There are 6 parts. So that means that one part must equal 3 because 6 times 3 is 18. 18 divided by 6 is 3. So each one of these parts is worth 3. So it'd be 3, 6, 9, 12, 15, 18. So this tells me then that if each part's worth 3, there must have been 6 people that said dogs. 3 more people had dogs than rabbits, which tells us then that rabbits is only 3 because 3 more people had dogs. So 6 had dogs, 3 had rabbits, and the rest is cats. So there was 9 cats. So with these pie charts then, they're all about the amount of games that each team has won, lost and drawn. 3 points for a win, 1 point for a draw, no points for a lose. So Borough Town have won 5, so 5 times 3 is 15. They've drawn 5, 5 times 1, because you get 1 point is 5. 5 add 15 is 20. The Rovers have won 5 again. 5 times 3 is 15. They have drawn 9. Each one of those is worth 1 point, so they have got a total score of 24. And County United, although they've actually won more than everybody else, because they've won 1, 2, 3, 4, 5, 6, 7. 7 times 3 is 21. Add 1 for a draw is 22. They still haven't been the best team. So Rovers wins with 24. Borough Town was the worst with 20. So there was a difference of 4 points. For B then, you had to make the pie chart show 16 points with 3 for a win and 1 for a draw. So there was 5 possible answers. So you could have done 5 wins and 1 draw, which is what I've done on the left. You could have done 4 wins and 4 draws, which I've done in the middle. Or you could have done 3 wins and 7 draws, which I've done on the right. But you could also have done 2 wins and 10 draws and 1 win and 13 draws. Well done if you got all of those right. For number 3 then, 800 people were asked if they played video games. So the whole is worth 800 and the pie chart is split into 8 parts. So if 800 people is the whole and there's 8 parts, 1 part is 100 people. So 200 people play once a week. So I've done that orange. If 1 part is 100, 2 parts is 200. 200 people sometimes play, so I've done that in green. So again, that's another 2 parts. And then you're left with 150 people and 250 people. Well, if one part is 100, 1.5 parts is 150, which is the dotty orange. So 250 would be 2.5 parts, which is the dotty green. Well done if you got those right. Right. I don't want you to have a go at doing the challenge today because I'm pretty sure that there is a typing error in this question. So I think what's wrong with it is I think that the pie chart should be split into 10 parts, and maybe it's my brain going, but I've counted it about 6 times and I keep counting it as in 9 parts or 9 segments. So I think that makes this question a bit tricky. So either leave the challenge completely, or if you want to do it, draw your own pie chart where it's split into 10 parts, and then you'll be able to have a go at it. Okay, well done for today. You have worked really, really hard, and I will see you next week. Bye.